Okay, tower safety. So even though Amanda's not going to climb a tower, she still needs to know this because it's on the test. Uh, you need to use appropriate safety gear, which means certified safety gear. If there's any electrical power on the tower, probably not on an amateur tower, but some of the bigger ones might have uh, AC power lines to power up equipment that's located up high up on it. You
Biggest
need,
power one that I've run across when I was doing that is the aviation lights.
yeah, it's high enough it could have a light on it. Right. Um, so you need to make sure that what they mean by circuit locked out is if there's a circuit breaker or switch to be turned off with some sort of tag on it showing that it needs to be off. So somebody doesn't inadvertently come by and turn it on while you're up there. You need to have a minimum of one ground crew person that has a cell phone or some means to call 911. If it's a crank up tower where they have telescoping sections and you crank up one section, there's locks on it that lock it in place, and then you crank up the next section. If you're going to climb one of those, you need to make sure that the locks that lock the sections together are in place. And you also need to have proper training, basically some sort of certification course on the proper techniques and all that stuff to climb a tower.
Years ago, we had somebody lose a couple of fingers on a crank up tower because he didn't have the locks, and he was partway there,
And
and the
it,
thing came down, and he had his fingers between the two sections as they telescope.
yeah, kind of a guillotine.
Yep.
Okay, so which of these choices should be observed when climbing a tower using a safety harness?
Bravo.
Delta.
Oh.
We have a discrepancy.
Yes.
He's usually right.
Somebody's wrong. Why did you say Delta?
Heavy tools must be secured.
Uh,
That's required from Crown Castle, an American Tower, and NASA.
okay,
Maybe it's not ever.
but it's not one of the choices.
Okay.
You should always hold on with one hand, I think, too, but that's not one of the choices.
Okay.
So it is Bravo. I actually have a harness. I don't ever intend to climb a tower, but I use it when I go on the roof and I tether myself on the roof
That's
to
smart.
where it's long enough I can't fall off the edge.
One
Linemen that work
thing,
on power lines definitely don't use both. They'll lean back and use both hands. They definitely don't hold down with one hand the whole time.
Yeah. I
yeah,
mean, that's just good practice, but it's not required that you hold on to the tower.
Smart.
Okay, what should be done by any person preparing to climb a tower that supports electrically powered devices?
bravo.
Bravo.
And if you can get lockout tags with padlocks on them, you're even safer.
Yeah. Okay. Uh, Grounding for a tower is important, mostly for lightning strikes. And you need to make mechanical connections of the ground wires. Solder with the current from a lightning strike will vaporize instantly, and you will no longer necessarily have a connection. So they need to be good mechanical, essentially airtight connections where it's torqued down enough that it's a metal to metal contact. You need to make sure that the legs, normally there are 3, maybe 4 legs on the tower, are bonded together and individually connected to a ground rod close by. So if you've had a lot of the cheaper towers that are triangular, you've got 3 ground rods, one off of each leg. And those should also be tied into your equipment ground over where you go into the shack.
They become your counterpoise.
A place for lightning to go, hopefully.
But when you're transmitting, they make a nice counterpoise.
Okay, why should solder joints not be used in lightning protection ground connections?
Alpha?
Yep. Should never use a soldered joint anywhere, basically on any ground that's possible to take very high currents like a lightning hit.
But you can use thermite.
Yes, but that's not solder. That actually melts,
Right.
welds the
Yep.
metal together. And they do sell those little kits, and you put it on each ground rod, and it does a welding job. It's kind of pricey. They're like 25, $50 each.
Wow.
I just have clamps that I torque down.
You used to be able to just buy the thermite and make your own.
Oh yeah, you probably can still do that. Which of the following is required for lightning protection ground rods?
Must be bonded together with all other grounds.
That sounds good. You don't want to use water and gas lines, especially nowadays, and they may not even be metal or all the way. So it's not a very reliable ground. You don't want to have 90-degree bends in your ground lines because that's basically creating an inductance. So you're going to impede the flow of current from the lightning and actually may cause it to jump to something close by.
And you sure don't want to connect them to ungrounded wire.
Right. Okay. Lightning arresters. You should have a lightning arrestor at the entrance to your shack for your feed line going to your antenna or antennas. If you have multiple antennas and feed lines, you should have one where each feed line enters your shack, your room, whatever you call it, some sort of entrance panel. And they should be grounded to your station ground that should be, and all of this needs to be outside of your shack. You don't want the lightning coming in and then hoping it goes back out. You want it to go to ground before it gets inside.
I made a real nice bus bar for my lightning protectors. I had a hunk of 3/4 inch K copper pipe and pounded it totally flat. And boy, that makes a real nice bus bar.
Flat copper strap is the optimum.
This was a whole lot cheaper than buying a.
I don't know. You priced copper pipe lately?
Compared to actual flat bars.
Okay, so you just need to make sure that you really ground them, and it's grounded outside of the building. And you should preferably do that with some sort of flat copper strap, or at least something like copper coated steel, because it will travel on the surface. Not braided copper braid or tin braid. That corrodes outside and doesn't hold up to the environment.
I use copper braid from the box on the outside coming into the shack.
Inside, it's okay. If it's out in the weather, it's not a good thing. Where should lightning arresters be located?
Alpha.
Alpha. Now, some people put one at the tower or the antenna or the mast also, but as a minimum, you need one where it enters the building. I guess you can't have too many. Where should the station's lightning protection ground system be located?
Bravo.
Right. You kind of want it like A, but outside.
Yeah.
Okay, so AC wiring or DC wiring, you need to make sure that you're using appropriate size wire and fuses. The National Electric Code has charts for the current carrying capacity of different size wires, and you're supposed to follow that.
And always pay attention to the length because it varies based on the length also.
And whether or not it's enclosed or in free space, or open air, I should say. So which of the following is covered by the National Electric Code?
C.
Charlie. So the appropriate wire sizes for a 20 amp circuit, you need a minimum of 12 gauge wire. For 15 amp, you need 14 gauge wire. Bigger is better, but you need, as a minimum, 12 and 14. And those are the two typical circuits you'll find in your house, a 20 amp or a 15 amp. Now, the wire size also applies to your transceiver and your DC power supply, because you're going to, for a 100-watt transceiver, you may pull 20, 22 amps when you're transmitting at a full 100 watts. According to the NEC, what's the minimum wire size that may be used safely for wiring with a 20 amp circuit breaker?
Charlie.
And that could also be a 20 amp fuse. What size of fuse or circuit breaker would be appropriate to use with a circuit that uses number 14 wire?
Delta.
Right.
That's why most lighting circuits use 14 gauge on a 15 amp circuit.
Right.
And the outlets.
Right.
Because wiring 12 gauge into a light fixture is a lot more difficult than wiring 14 into a light fixture.
And it costs more.
It also is harder on your fingers trying to squeeze it in the box.
Yes. Try 10 gauge sometime.
I've got 8 gauge on my trailer.
Okay, GFCI. They're not required, but it's kind of recommended that you use ground fault circuit interrupters on your outlets. They are required by the NEC if you're in an area like a laundry room, kitchen where there's water.
They're within 10 foot of water.
Yeah. And the way these things work is they look at the difference in current between the hot and the neutral. And they should be identical. You should have the same amount of current going out the hot line that's coming back on the neutral, or the other way around, depending on how you want to look at it. If there's a difference in the current, it's assumed that it's a short to something, to ground somewhere or the safety ground, and it will trip the breaker. And I don't know what the minimum difference in current is, but it's pretty small. Doesn't take much to trip it.
I have some that trip every time lightning hits within a block of me.
Which of the following conditions will cause a ground fault circuit interrupter to disconnect AC power?
Delta?
Say that again?
I guessed delta. Definitely a guess though.
Nope.
Yeah.
Well, it's not A because that's how it's supposed to work. You're supposed to have current on the hot wire, to the neutral wire.
Bravo.
Through the load. So they assume that because there's a difference in the current, it's got to be going somewhere. And they kind of assume it's going directly to ground. It doesn't really matter where it's going. The fact that there's a difference in the current will trip the breaker.
Okay.
Oh, Ernie showed up. And an overvoltage on the hot wire, unless it somehow could create a difference in current between the hot and the neutral, wouldn't trip it either.
The neutral and the ground
Are not
bonded at one location
correct.
only.
At your service entrance.
At the service entrance.
Okay, sometimes you may need a 240 volt circuit, like if you put in a 1500 watt linear amplifier, it's going to draw more than 20 amps probably. So you need to put it on a 240 volt circuit. And the NEC has some specific wiring requirements when you do that. And it's also a good idea to use GFCI breakers, even if you're not within 10 feet of water. This is a thing I drew, a typical AC installation where this is the transformer you see out on a power pole, unless it's underground, and then it'll be one of those little green boxes sitting somewhere. And you have essentially 3 lines coming to your house. So you have 240 volts off of this transformer with a center tap. So it's 120 volts on each side. And when they get to your entrance panel, your service entrance, the neutral is connected to what's called safety ground, and that's connected to a ground rod right outside right below your meter. Once you're inside the house, okay, you carry the safety ground along with the neutral. They're never connected together. There's only one point where they should be connected together. And that's true for the 240 volt circuit, where you got 2 hot leads and you still carry the safety ground. Now, in some cases, you may have a 4-wire 240 volt circuit where you also have the neutral. An example of that would be your range or stove in the kitchen will normally have a 4-wire circuit, and they run the lower wattage burners off 120 volts. So you have both 120 available and 240. You have 240 on the oven. The burners may be 120. Anything to add, Ernie?
No, that's good.
Okay.
Except the color of the wires.
Oh yeah, color of the wires.
Black is always ground. And in the house. I'm sorry.
No.
Black is always hot. I'm sorry. Black and red.
Right.
White is always ground.
Yeah. Neutral, which is usually white or some off-white, is always the neutral. And a color, black or red, is the hot wire.
Yeah. Black is normally
120 is normally black.
Okay. And most of us don't have 3-phase, 480, 277 3-phase coming.
Right.
That's rare.
Okay. Which wire or wires in a 4-conductor 240 volt AC circuit should be attached to fuses or circuit breakers? I guess I didn't talk about that, but
only the hot wires.
Only the hot wires. You know, like here in the 240, both of them are, I'm showing fuses because I didn't have a symbol for a circuit breaker.
Both.
But if you've got an old house, it could still be a fuse.
Yep.
But you're not supposed to put pennies in.
On your radio itself, they normally fuse both the hot and the cold.
Yes.
Why? I don't know.
On the DC,
me either.
On the DC power.
Yeah.
Yes.
Side. Yes.
Definitely on mobiles, but even my 2 base station radios, the power cords that come with them have fuses at the power supply end on both the positive and negative.
Well, that's because neither the negative or positive on the DC is legally a ground. They're both carrying current.
True. And we don't have a safety ground there in those situations.
Exactly.
Okay, so backed up too far. We did that one. All right. Interlocks. This isn't too common, but on something with a high voltage, high power in it, like some of the old tube type linear amplifiers, or maybe even transmitters, where you've got several hundred volts in there. A lot of times they'll have an interlock, so when you open the cabinet, take the lid off, whatever, it disconnects power to the unit. You need to make sure that the power is disconnected when you open up the cabinet, take the lid off, whatever, when you get inside, because 300 and 400 volts will
get actually into
make you
thousands.
Yeah.
And maybe in the
It'll
thousands.
get your attention.
Yes, quickly.
Especially when it jumps an arc about 3/4 of an inch.
What is the purpose? And you should also make sure the capacitors are discharged.
That's what a grounding rod is for.
Especially if they don't have bleeder resistors.
Huh?
Especially if they don't have bleeder resistors on them.
Sure.
What is the purpose of a power supply interlock? Charlie. Okay, emergency operation on batteries or generators. You should always disconnect your utility feed before turning on a generator that you're going to use as an alternate supply. And that sort of happens, I guess, automatically if you've got one of these failover switches for your expensive backup generator.
The last thing you need to do is backfeed the power line.
Mine is an auto switch.
That's the way is the what?
Auto switch.
Yeah.
Mine isn't. I have a 30 amp plug. I got to turn off the main breaker if I'm backfeeding the house.
I did that for a little while when I had a portable generator.
Okay, the generator should be located in a well-ventilated area, not in your house, preferably not in the garage when it's operating anyway. Because of the danger of carbon monoxide poisoning. And if you had it, for instance, in the garage where there's possibly gasoline fumes, it could do more than poison you from carbon monoxide. It could blow up.
One that I have seen a lot of people mess up and get injured. If you have two generators, make sure that they are on a common ground and common grounding rod. If not, one's floating the neutral at a slightly different voltage and it'll really zap you.
What's even worse, if they get connected together and then they're not synchronized.
Yeah.
Normally if you have more than one generator, they're phase locked.
Yep.
Right.
One is the primary, one is the secondary.
Not a big problem when they're DC supplies. It's a little bit, but
yeah,
not nearly as much as AC being out of 180 out of phase. Which of the following is true of an emergency generator installation?
Alpha.
Yeah. C is definitely out. Okay, lead. They still consider lead a hazardous material. They claim it made some of the old Romans go crazy because of the lead-lined viaducts. If you're doing soldering or even working on equipment that has solder connections, you will be in contact with it and you can get it on your hands. If you're actually soldering, you can get vapor from it. So you need to always wash your hands so that you don't go and eat something and get lead contamination.
Or use silver solder.
Okay, or use silver solder, but we don't normally do that on electronics because of the heat required. You wouldn't have a circuit board. I think you'd have to have a lot of solder to get food contamination, but
I used to.
Yeah, I do too. I still do.
Yep. I can't do it anymore. I can't even solder anymore.
I do not use that fake solder.
I have
real lead 10 6337.
I have 6040.
Well, see, that's a higher temperature.
Yeah.
The 6337 melts at a lower temperature. That's the one thing I learned. One of the two things I learned in thermodynamics.
Oh.
The other one was how to make icebox brandy.
It's sticking in the freezer.
Take wine in the freezer until the ice crystallizes and you filter the ice out and you got brandy. Okay. Which is nothing to do with
No, that's the important part.
Lead can contaminate food if hands are not washed carefully after handling solder. And it's time for a coffee break, and Ernie's already there.
I got mine.
Talk about the stupidity of people.